Hi everyone, this is John Christensen, and for my research paper I wrote about the evolution of whales. So just a quick introduction, we all know that whales are large aquatic mammals, and there are about 40 different types of whales today, but obviously they all originated from a single common ancestor. And although whales live in the oceans today, this doesn't necessarily mean that this common ancestor lived in the ocean as well. In fact, Darwin was one of the first to hypothesize that whales derived from a land-dwelling mammal. He thought that they came from bears, but he didn't have very much evidence to prove this, and so he didn't pursue that idea for too long. But we know that it is possible for this transition from land to sea to occur, and thorough research has been done to address this question of where did whales originate. And although the discovery at the time was somewhat controversial due to the lack of physical evidence, we know that whales are descendants of what once were only land-dwelling mammals. This transition must have taken millions of years to occur, but we do know that this transition did occur, and it can be proven through many different forms of evidence. And so some of the first most basic evidence used are some of these whale characteristics that are found only in whales. One of them being their thick rounded bodies as compared to other sea-dwelling mammals. Also their tails span horizontally as opposed to vertically like sharks or fish. And then also unique bone structures, which although they're only unique to whales, they are definitely more closely related or have connections to land-dwelling mammals as compared to sea-dwelling mammals. So they're more similar to these land-dwelling mammals, which cause people to think that maybe there is this connection between them and land mammals. And so in 1936, Remington Kellogg first wrote a paper about whales and basically everything that they knew about whales at the time. And he believed that they did originate from a land-dwelling mammal, but he was not able to prove this because he didn't have any evidence to show that. And in fact, in this slide, this picture was published in a major science journal at the time, showing kind of in a humorous way this transition from land to sea. But in reality, this is somewhat what it should look like, with these different transition states or these transition forms occurring, showing that the different characteristics developing, and those characteristics should be able to be seen in fossils of whales ancestors. And so starting with the whale ancestor fossil line can really show these major characteristics and these changes happening. So the first or oldest known whale ancestor was called Synonyx, and Synonyx was a mesonychid, which can be described as a primitive ungulate that lived about 60 million years ago. Some of his major characteristics were this long snout and these teeth that are similar to some fish hunting sea mammals of today, which weren't common characteristics among the mesonychids. And so this shows that he already was starting to develop some sea mammal characteristics. Next was Pakicetus, which had an even more elongated snout, and his teeth were changing even more to look more similar to what we see in fish hunting mammals, sea mammals of today. Although both of these mammals primarily dwelled on land, we do know that they were able to swim in water, and they kind of like paddled with their hind legs in order to get across water. Next in line was the Ambulocetus, and Ambulocetus still walked on the land, but he most likely, scientists have been able to discover that he kind of more like waddled, kind of like what we see with sea lions today, instead of normal walking like what most other land mammals do. And so he also had hooves still, and so even though he was in the water a lot more than the previous species, he still had hooves, and he waddled on land. Next in line was Rodhocetus, which this is a picture of the fossils of Rodhocetus, and he started to develop even more characteristics that were helping them transition to the sea. One of them being his sacrum wasn't fused anymore, which allowed for flexible movements and to be able to develop a swimming movement, which helped him obviously swim better. And they also believe that Ratacetus had a tail. And Ratacetus also is considered to be the first to start having very reduced abilities to walk on land. Next in line was Basilosaurus, and one of the main characteristics of Basilosaurus that showed this transition occurring was his development of what we see in whales today as blowholes. He had a single nostril, and with time, this nostril started to go more to the back of and top of the head, like what we see in whales today. Next in line was Dorudon, and Dorudon is considered to be one of the oldest aquatic ancestors to modern whales. So it was a fully aquatic mammal that couldn't dwell on land, and they know that because it was very large, but it lacked limbs to be able to support that large body on land, so it obviously was an aquatic mammal. So the discovery of all of these fossils and seeing these changes occur over time was very essential to be able to prove that this transition from land to sea really did occur. And all this was probably the major piece of evidence to show that this really did happen. It wasn't the only piece of evidence. So next we had vestigial structures and embryonic development that could be used to show this transition occurring. Some vestigial structures that whales have are femur bones, and obviously femur bones are used for walking, but whales swim, and so this obviously means that their ancestors must have had femur bones and are not used today by whales. They also have ear muscles to kind of help move what would be an outer ear in different directions to be able to hear better. But obviously we know whales don't have ears, but this means that their ancestors most likely had ears, like what we see in mammals, land mammals today. They also have a diaphragm, but it's very weak and doesn't have very much muscle, mostly because they don't really use that the diaphragm to breathe. But again, this shows that their ancestors must have had a diaphragm that was used for breathing. Also, in embryonic development, whale embryos, when they're in the womb, they grow hair, they develop hair. And obviously before they're born, they lose this hair because whales don't have hair. But this just shows that they still have genes that can be transcribed to produce hair on their bodies, meaning that their genes do these things. And so this just shows that their ancestors must have had these same genes as well, most likely to produce hair like what we see in most mammals, land mammals today. Another type of evidence was paleoenvironmental and paleobiogeographical evidence. And paleoenvironmental evidence is the idea that finding fossils of those major whale ancestors, that if we found a Synonyx fossil on land, we should be able to find other fossils of different types of species that were also primarily land-dwelling species. Or if we found a Dorudon fossil, we would also find other fossils of different species that were primarily aquatic mammals. And so this idea was confirmed by the discovery of a Pakicetus fossil that was also found, that other fossils were found around it in the same area and the same time, of rodents and bats, which were land-dwelling mammals, obviously, but also other fossils of fish and crocodiles were found in the same area, showing that Pakicetus spent time on land and on sea. And then paleobiogeographical evidence is the idea that land-dwelling mammals' fossils should be found in a more concentrated area, and as compared to aquatic mammals should be able to be found all over. Their fossils should be able to be found all over the world because of their larger environment that they can live in. And this idea has been confirmed with Synonyx fossils only being found in Central Asia and Pakicetus fossils only being found in Pakistan, while Basilosaurus and Dorudon fossils have been found basically all over the earth, from as far as southern Asia to British Columbia. And so all of this evidence has been used to show that this transition really did occur, but there also had to be a reason for them to want to move to the ocean. And so we know that at the time, early, like in Synonyx time periods, that there were many large reptiles and predators that lived in the ocean that would keep Synonyx and other whale ancestors away from the sea. But there was a mass extinction that occurred, and all of these predators basically were wiped out, and so the ocean was now available for these mammals to go and um, move into the sea and to take advantage of that new opportunity of new resources. And so that's exactly what they did. With that, they gained many advantages as compared to land-dwelling mammals. They were able to go and move in more areas and be more spread out, and so there was less competition. And also, at that time, there were more food resources and other nutrients that just weren't available on land. And so it made sense for them to go and habitat those areas, that other mammals weren't able to, and so they would be able to take advantage of those food and resources. And so, my conclusion and kind of why this is important, for me, it was that understanding evolutionary relationships and how they change and transition over time is essential to our knowledge of how life all around us works. We know that species adapt and change due to challenges from the environment, and noticing those patterns can help us predict evolutionary relationships. And so studying whales is very ideal because this hypothesis was made, and then all this kind of evidence was able to be found to prove that this transition did occur. And so we know a lot more about whales and their relationship to other species and their relatives and how they came to be what they are today. And so not all studies, obviously, in evolution are this convenient and have all the evidence to prove everything that we want to know. But studying and working to put all the evolutionary pieces together from many different fields of evidence can be used to show and learn more about relationships between other species and origins of other species, and overall we'll just be able to learn a lot more about the world around us and all these other species. And so that was my paper, and these are my references. Thank you very much.